Hello everybody, and welcome to exercise 3 on page 47 of the workbook. This is the last exercise in this section, and this is kind of a challenging exercise. It really requires that we put together a couple of different elements to do this problem. Okay, so let's read this together and see if we can make sense out of this. So let f and g be the functions given by the graphs below. I guess they're to the right, not below. Okay, those are these graphs that were given. And define the following new functions. Okay, so we've got three functions, u, v, and w here. And they'd like us to calculate some derivatives of these functions. Okay, u prime of 1, v prime of 8, and w prime of 8. Okay, how do we do all of that? Well, let's start with this first calculation. I think if we can make sense out of that, then the second two won't be as bad. Okay, so they're asking us to calculate the derivative of u and then to substitute 1 in. Okay, so that means that we're referring to this formula up here. So let's start by asking the question, how would we calculate the derivative of u? Well, notice that u is a product of f times g, and so to take its derivative, we need to use the product rule. So we're going to get the first times the derivative of the second, plus the second times the derivative of the first. And there's our formula for u prime. And so to get u prime of 1, we need to substitute 1 into that formula that we just found. Okay, and actually it might be useful to have a little bit more space here, so let me move down a bit. So if we substitute 1 in for all of our x's, here's what we're going to get. Okay, now to finish this question, we would like to boil this down to one number if we can. Okay, so what it comes down to is, can we find numbers for the quantities that we're seeing on the right-hand side of our equation? And let's start with the two pieces that I think are maybe a little easier, the f of 1 and the g of 1. How do we get numbers for those two pieces? Well, we can use the graphs that were given over here to the right. So f of 1 and g of 1 are just y values of our two functions. So we'll find the point 1, and let's start with f of 1. That would be the y value that we're getting right there. What would you estimate that to be? That to me looks like about 1.5, okay, for that first number. So we'll fill that in. Okay, and I'm going to leave g prime of 1 blank. And what about g of 1? Well, same idea. We're going to go to our function g. Notice that the y value there is 6. Okay, so we're going to get 6 times f prime of 1, which we'll fill in a minute. Okay, and now we come to the last two pieces. What about g prime of 1? What is the geometric meaning of that? That is the derivative of g at the number 1. What does the derivative represent geometrically again? The derivative is a slope. Okay, so we need the slope of g at x equals 1 to fill that in. Okay, so let's find the relevant point. That's sitting here. We need to know what is the slope of the line, this line that point is sitting on, basically. Okay, so to find the slope of a line, we can use rise over run. Let's pick a couple of nice points, maybe this point here and this point here. And how far down and over do we go? Notice that that's a distance of 2, and that's a distance of 1 on our scale. So the slope should be minus 2 over 1, because we go down 2 and over 1. Okay, so we're going to just get a negative 2 over 1 for that. Okay, and then same idea for the f prime of 1. This time we're talking about the slope of f at the number 1. Okay, and here's the function f. And so we want to know what's the slope of this line. So we'll pick a couple of nice points again. How about this point and this point maybe? They have some nice round number coordinates. And then the rise over the run, let's see, what distances are we talking about? So from here to here, that's an x distance of 2 and a y distance of 3. So we're going to get a slope of 3 over 2. We go up 3 and over 2. Okay, so that's the number that we should get there. Okay, and the rest is doing our calculations. So we've got 1.5 times negative 2. That's going to give us a negative 3. And then plus 6 times 3 over 2, that's 18 over 2, which is going to be 9. So we're going to get negative 3 plus 9, which is 6. And that 6 is the first of the three answers. We have just calculated u prime of 1. Okay, and so now we're ready for the next piece. What about v prime of 8? Well, the formula for v is sitting here. It's f of x over g of x, so to take that derivative, we're going to need the quotient rule. All right, so that means that v prime of 8 is going to look like, if we apply the quotient rule, low d high minus high d low. Whoops, I'm sorry, we're plugging in 8 already. All over low squared. Okay, and we kind of do all of this again now. All that's changed really is the location. Now it's the number 8 that we're plugging in everywhere. So let's start with the, I'll put it in quotation marks, easier numbers, the ones that we can get without taking derivatives. G of 8 and f of 8, that's just about what's happening on our graph at the point 8. So let's see, this would be, let me scroll up a little bit here. G of 8 would be the y value at this point. That appears to be 2. And then f of 8, that appears to be 5, the y value there. So let's go ahead and fill those 2 points in. Okay, so g of 8 is 2. We'll leave the derivative blank for a minute. And f of 8 is 5. Okay, and in the bottom we've got a g of 8 squared, so that's going to be a 2 squared. Okay, and what about the derivatives? Okay, so if we want to calculate, for example, f prime of 8, that is the slope of the graph f at x equals 8. Okay, so we'll find the graph of f at x equals 8. We're looking for the slope of this line that I'm highlighting. So let's find a couple of nice points. How about this point and this point? Okay, we'll measure the rise over the run. Notice that we're going down 1 and over 4, it looks like. So that should be a slope of negative 1/4. Okay, if we fill that in. Okay, and then we come to g prime of 8. That's the slope of the graph g at 8. Okay, so we're looking for the slope of this part of our graph. And 2 nice points there would be maybe this point and that point. Okay, you don't have to choose the same points that I do. That really doesn't matter. I'm just trying to choose points with nice numbers. And let's see, there we're getting a horizontal distance of 2 and a vertical distance of 1. So we're going up 1 and over 2. That would be a rise over run of 1/2. Okay, and the rest of this is just calculating these numbers. So let's see, we've got 2 times negative 1/4, that's a negative 1/2. Minus a 5/2 over 2 squared, which is 4 in the denominator. And if you simplify this, this should come out to be negative 3/4. You can double check my arithmetic there. Okay, we've got one part to go. So the last thing they'd like us to calculate is w prime of 8. Okay, our formula for w is sitting right here, e to the x f of x. So we need to start by taking the derivative of that. And notice that e to the x f of x is a product, so we're going to use the product rule. So the first times the derivative of the second plus the second times the derivative of the first. What is the derivative of e to the x? It's still e to the x. Okay, and so that's what our derivative formula would look like. And we're going to substitute, let's see, what do they want us to plug in? 8, it looks like. Okay, so we'll plug in 8 for all of those x's. Okay, now here's what's kind of nice. These two numbers, f prime of 8 and f of 8, we actually already calculated those above. F prime of 8 was this number here, negative 1/4, and f of 8 was 5, so we can just use those numbers. They haven't changed. We're going to get e to the 8 times negative 1/4 plus 5 times e to the 8. Okay, and last step here would be, you could go to your calculator and get a decimal number for this. You would find, though, that e to the 8 is a pretty big number. I'm going to choose to leave this algebraic. We can maybe get a common denominator here. This is e to the 8th times 1/4 plus 5. I'm going to rewrite 5 as 20 over 4, just so that we've got a common denominator of 4. And the reason for doing that is it allows us to combine -1/4 and 20/4. If we add those two fractions, we're going to get a positive 19/4 times e to the 8. Okay, and there would be our answer for w prime of 8.